Okay, so welcome to Math 12. This should be the mathematics of Legos. Let's see, is it working today? Yes, it's working today. Excellent. And so the only difference is last year we were in 202. This year we're in Bronfman B34. If you are here right now, that means you have figured that out. If you are not here, don't look at that part on the web. I was too lazy to change things, and this way I can keep last year's homepage. Okay, this is the safest room on campus. We are not exposed to anything outside. If there is an attack, we are deep down in the sub-basement. We will be very safe. Hopefully, in the new Bronfman construction, we will not have rooms like this. Is there, hopefully, we can hope. Is there anyone here who has not played with Legos before? Okay. Excellent. So everyone has at least played with some Legos before. There's a lot of different ways we can go with this class. What I want to do today is I want to talk a little bit about some of the things we can do. We have enough people that we can break up into lots of different subgroups. I want to talk a little bit about the mathematics behind Legos, or if you care about other subjects such as biology, chemistry, how you can use Legos for stuff like that. Out of curiosity, how many people are math majors here? All right. Some. How many of you have gone beyond real analysis? Okay. So not too many. So if I am doing things that you have seen before, try to look interested. Okay? But most of you hopefully have not seen this. How many of you have not seen binomial coefficients and combinatorics? Good, so you can learn some stuff. Excellent, right? So we can use this as a springboard to talk about some good mathematics. How many people are chemistry majors? No chemistry majors. Biology majors, or prospective biology majors. Physics, computer science, economics. Something in Div 2, I'm biased. Something in Div 1. Any other divs? We seem to be a little short on counting. Okay, so what I want to do is talk a little bit about some of the possibilities. So the main goals, some kind of MLK, Martin Luther King event. Last year we did a bridge build. My goal was to have students suspended from the ceiling. Unfortunately, you need to get permission from not just public safety, but from the town to build the superstructures we need. But we actually were able to build a bridge spanning the fireplace mantle in Peresky. I would love to have a bridge going the entire gap. Now, that would be a real challenge. There would be difficulties in that, both in terms of actually constructing it, as well as, unfortunately, legally, how we would be allowed to build it. You know, if people are interested in something like this, you can have like little Lego communities bridging, building it together. There's a lot of really nice imagery we can do. Let me know. That's going to be one of the groups. Right? I'm figuring with 40 people, odds are there should be a subset of you who are interested in something like this. One of the mistakes we made last year is we built the two towers straight up. What's wrong with that? I'm sorry? Yeah, they start pulling each other in. And so even though the base plates weren't that heavy, just the length of it was enough that it was actually pushing the two towers, which were solid, towards each other. So we had lots of things going in the opposite directions to try to pull them out. I think this year, if we do, we should actually try to build the towers at an angle, so that as they're pulling in, it would hopefully stabilize a bit. So there could be some really nice, interesting engineering challenges to see what is the greatest distance we can span in real time. And we can do some practice builds and whatnot, but a lot of it's just doing it on the fly, problem solving, spur of the moment. Another one is a Lego idea challenge. How many of you have seen Lego ideas? So you put up something on the web, and if you can get 10,000 people to support it, Lego will consider building it. 10,000 people is not going to be difficult. You know, if we have a good product, this is the era of social media, we've got 40 people in the class, you have friends, family members, you can get people to just go and log on and do that. The difficulty is finding something that Lego would then choose to build. So what do you think would be the issues? Yes?
Copyright problems.
So one is copyright problems. So Lego is very different now than when I was a child. When I was a child, Lego was much better. The sets sucked. Okay? No one wanted to keep the spaceship or the city buildings or whatnot. They were horrible. So you would just break them down and you would put them in a big bucket. Nowadays, the sets are actually good. They're things you would want. And so the kids today, I think, are much less likely to actually just break sets up and just build. Now, when Lego was building the crappy spaceships from the 70s and 80s when I was growing up, they didn't really have to pay anything. They just had people making up ships. Now they have to pay an enormous amount of money to what companies? I can't. NASA. So there was the Mars rover, which was the Lego idea. NASA might be kind enough to give it to them for free, but probably doubt it. Who else? Disney. Disney has a huge number of things, right? What else? I'm sorry? Warner Brothers. You've got all the Batman stuff. JKK Rowling's, you have the Harry Potter stuff. They have all these different lines now. Why do you think Lego does this? Yeah.
They know it'll sell better.
They know it will sell better, or they think it will sell better. So this is a really interesting business question. How many of you are considering some kind of career in business or industry? I should have far more consultants or something like this in a Williams class, right? You've got to decide, is this profitable? How much money are we going to have to pay for these rights? And will we recoup it? Lego is a very different company now than it was 20 years ago. Let's say you are Disney, and Lego approaches you and says, we would like to do Lego Star Wars. What do you say if you're Disney? Or before Disney, if you're George Lucas? There was a story a couple of years ago about, I'm not sure if they were married or if they were just dating, but a couple went to Disney and they thought it would be romantic to dress up as Disney characters and walk through the park. What had happened to them? Yes? They asked them to change. Disney security got to them very quickly and escorted them. And they actually gave them clothes from one of the gift shops. But they did not want a non-Disney employee to be representing their line. They care greatly about the image of the product. So one thing is, you're not going to want a crappy set, if you're Disney. And the other thing is, how much money are you going to get from it? And how would you calculate how much money? It's not just the sales of the set, but it's increasing demand for the whole Star Wars line. What could be one of the fears about Disney? This sounds like a great deal. We'll get some money from selling the Disney Lego sets. Looks like a great design. Sure, let's go with it. Why might it be a bad deal for Disney? Yeah. They might stop buying other Star Wars stuff. Maybe you don't buy now the cast iron X-Wing, and you buy the Lego X-Wing instead. So really, even though it's profitable, maybe you're just transferring sales from one arm of Disney to another. And so it's a really interesting question as to how much will you gain from something like this. So there's a lot of good questions that we can explore when we're trying to decide something like this. There's a lot of good for just spreading out the word, good press. And so for Disney, it is worth something to have the stuff on the shelves, to have people seeing this, to have people buying the stuff. Okay, so one thing is, if we're trying to do a Lego build, would we have a copyright issue? One of the Lego ideas that's being voted on right now, I don't know if any of you watch the TV show Friends. So they have Central Perk. So somebody made the coffee shop from Friends, and they're trying to get to 10,000 votes. If that goes through, there is going to be copyright issues. And Lego would have to decide, is this worth it? I think they have done the Big Bang Lego set, right? So I actually know one of the actresses on Big Bang. We went to college together. And so for something like that, Lego decided, yes, it's worth exploring and getting the copyright for something like this. I believe the Big Bang recently beat out Sunday Night Football, which was the first for Sunday Night Football not to have the highest market share. Part of it is also, I think, the matchups on Sunday Night and Monday Night Football this year have not been the best matchups. But Big Bang actually beat out Sunday Night Football. So when you're trying to decide for a Lego idea, one item that you have to consider is copyright issue. There's another. Let's say we decide to make the greatest purple cow ever, and it's wonderful. And not surprisingly, our friends and our family members love the idea of a Lego purple cow. What could be the problem with that? Yes?
Affordability to the average consumer.
So one is affordability. But let's say that you guys do a great job and have a wonderful cost analysis and the set isn't that expensive. What could be the problem? Yes?
No one outside of Williams really wants a purple.
Very few people outside of Williams will want a purple cow. Now, at least if it was like a bulldog. I mean, there's a lot of schools that have bulldog as a mascot. So for something like that, you could potentially use it for lots of different places. The purple cow, it's not going to be that popular. And so Lego might say, it's a beautiful purple cow, but we don't really see it selling enough. I will date myself. Anybody ever see the old anime TV show Voltron? The 5-lion version? So this is one of the sets that just reached 10,000. And so my brother and I grew up watching that show. You have the 5 lions that form together and make the super robot. And that's something that I think my brother and I would love to get. But most kids today, most college students have not really seen something like that. They may not be as excited about this. This brings another interesting point as to what Lego's business model is. When Lego started, who was Lego's customer? Kids. Why? This is one of the easier questions. It's a toy, right? Turns out that's wrong. It was thought for years that Lego is just a toy, not a lifetime passion. I think the phrase Lego is from 2 Dutch words that were subsets of Dutch words that basically mean let's play. And their whole business model was, we are a toy company, we're selling toys for kids. One of the things we're going to be doing is Lego Mindstorm for some of you who want to go to the elementary school. I've got a couple of boxes of stuff like that here and books. And Lego came out with these new lines, and people started hacking into the Mindstorm system. And Lego was very upset. And then they had an epiphany. Wait a minute. These are engineers making good salaries who don't need to convince mommy and daddy to buy them a set and are willing to buy 5 or 6 of them at a time at really high prices. And this is bad? And so there's now an entire adult fan base of Lego and an entire market for something like this. And this was a real concern for Lego as to they were afraid that it would change the view of their product if too many adults were playing with it. Then they realized how much money they could be making selling Legos to adults. And that it doesn't have to be destroying the other market as well. And so this is a good thing to look at as to how markets change. How many of you took the train to get here? Not one person. 100 years ago, I'm sure some people would have come back to Williamstown by train. Why is no one taking the train now? Yeah.
Markets evolved.
Markets evolved. Things are now done by ear, and the train industry really focused on the wrong things. There's a couple of places where the train market is still cost effective and still profitable. Which parts of the country is the train market effective? I'm sorry? I'm not sure if the Midwest is still profitable. Yeah, connecting the eastern seaboard. Boston down to DC, that route is still making money. I think it's really tough to tell how profitable various things are because there's all these different hidden subsidies, and it's not very. You can't just look at the revenue they're getting. You have to look at, are they being charged for maintenance? Are they being charged for train tracks? What are the different taxes and everything? But there's a lot of traffic going on the eastern seaboard that you could actually have profitable Boston to New York by train. And when you consider how long it takes to go by airport and where you land, going through security and whatnot, it's actually more convenient for a lot of people to just take the train. It's a more comfortable ride. And so you could have that market still being effective. You really want to think what your market is and to protect it. Anybody have a Blockbuster card? I've got a couple somewhere in my room. I think I might have actually just deleted them when we were doing a New Year's cleaning today. Anybody have a Netflix or an Amazon Prime account? I believe Blockbuster had the opportunity to buy Netflix. They're not going to compete with us. People want to go into a store and physically pick up a movie. You really need to know where the market is going. It's very easy after the fact. But can you figure out where the trends are? And so again, there's a lot of different ways we can go with this semester. This is a great thing to explore. A lot of you will probably be working in jobs that do not exist right now. So I'm also teaching a Star Trek class with Professor Stark in physics, and one of the episodes I'm going to be showing, any original Star Trek fans? All right, so I'll be showing the ultimate computer, which is basically talking about essentially people being replaced by computers. What skills are you learning? How much are you learning in college that's actually going to serve you once you leave college? Most of it's not going to really help you at all in your life. Most of the facts you learn will not be useful. What will be useful? What are we doing that's helping you? Hopefully we're doing something. What? Yes? I'm sorry?
Critical thinking.
Critical thinking. Which is to some extent Google, Wikipedia. It's how do you search for things? How do you take new information? How do you process it? And so while the specific facts don't matter as much, the ability to take a bunch of disparate facts and combine them and to do something meaningful and get action items. Interaction, skills, being comfortable speaking up, networking. But in terms of the facts we teach you, most of that you're not going to use. And so it's really worth thinking about how things are going right now. So for the Lego ideas, if you want to go this route, it's got to be a product that a lot of people will want. It's got to be cost effective. If there is a copyright issue, the question becomes how expensive is that copyright issue going to be? Can you make a compelling case to someone? Anybody see the movie E.T.? Do you remember the scene with the M&Ms? Good. Why weren't they M&Ms? Yeah, M&M said no. Reese's Pieces said, sure. We'll take marketing exposure, absolutely. And sales of Reese's Pieces went through the roof. So there are times when it is worth doing something. Even if it's not doing a great job for you, it could be stopping your competitor. I am a huge baseball fan. What's the best team in baseball? Red Sox, absolutely. And the evil empire is located where? New York. All right. So a couple of years ago, the Red Sox had I think the best number 4 pitcher in baseball, Tim Wakefield. He could eat up innings. He was a knuckleballer. He pitched into his 40s. He was wonderful. He would occasionally throw gems as well as just horrible, horrible games. The problem with a knuckleballer is the pitch is a little erratic. It's very tough to catch. And so the Red Sox had to catch a Doug Mirabelli who could catch Tim Wakefield. Well, Tim Wakefield would pitch every 4th or 5th game, and that's essentially all Doug Mirabelli played. And he got tired of this. He wanted to be a starting catcher. And so he was traded to the San Diego Padres, and he really didn't do that well. And so he was essentially losing his starting job in the Padres. And so the Red Sox wanted him back. It turns out another team also wanted Doug Mirabelli. Which team wanted Doug Mirabelli? The Yankees. Why did they want him? To stop the Red Sox from having him. The Yankees were quite content to have Doug Mirabelli and send him to their farm system or to have him as a backup catcher. Because if the Red Sox didn't have Mirabelli, Wakefield would not be as effective. And so it was a good use of the Yankee resources. The Red Sox were able to get Mirabelli, and in probably an abuse of state funds, well, we've got to be very careful, this is being recorded. I'm sure no state funds were used, but they actually flew Mirabelli to Boston the day of a game, and he had a police escort, and he was changing in the van on the way from Logan Airport to the Red Sox game in Fenway Park, and got there just before the game started. You really want to think about how you should allocate your resources. So, again, I'm just trying to give you a bunch of things that we can think about. We've got a couple of weeks. There's a lot of great starting points. So we'll talk a little bit later about who's interested in something like that. Big one is the outreach with the elementary school. So I have 2 kids. Cam is 9, Kayla is 7. Cam will definitely be in the Lego class. I'm not sure if Kayla will be joining us for that or not. The idea is to try to do fun things with them. We get them for about 2 hours on Wednesdays from, I think it's 1:30 to 3:30. We have a half day every Wednesday in Williamstown. And so school ends early on that day. So I have never done Lego Mindstorm. Is there anybody here who has done Lego Mindstorm? Of those who have done Lego Mindstorm, how many of you are interested in doing the outreach in the elementary school? Excellent. So there will be at least a contingent. So we'll talk more about that later today when we start breaking up into pieces. Sorry, groups, not pieces. But I think this would be a fun way to try to excite the kids about programming. You can also use Legos to do lots of various things. So, I bought a bunch of blocks like this a couple of years ago. In the interest of time, I'm not going to split them up. How many of you have done the Towers of Hanoi? So I'll start off with a smaller version here. So the way it typically works is you start off with a pile, and each piece is one larger than the one above it. And you have 3 piles, and the rule is you can never put a piece on top of a piece that's smaller. And so the question is it possible to move everything from one pile to another pile? If you only had 2 piles, would it be possible? No, your first move would have to be take this piece off, and now you're stuck. If you have 3 piles, your first move is take this off, and then you have to move this to the next pile. And then your only move after that is to then move that piece over here and have a blank pile. This is a nice way, we might do this later in the class, this is a nice way to learn about induction or recursion. So there's a way to do it. So we can actually build some of these math challenges with stuff like this. One of the problems is this is not a good one to do because a subset of these kids have already seen it because I've been going into the elementary schools and doing mathematics with them. But for those of you who are going, try to think of some good fun math that we can do, using Lego bricks or stuff like that to illustrate. Fibonacci numbers is another good thing to do with Lego bricks, but we've got to be careful because a good number of my son's friends, not surprisingly, got into the class. Entirely coincidental. All right, what else? So a little bit about my qualifications. I have been playing with Legos for years. I even had my wedding cake with the base built out of Legos, although the imagery seems to be, the top is actually Twisties, which is another class. The other thing which I often like to do is the little challenges. So one of the rules I have with my kids is whenever they're building a Lego set, I have to build small things with whatever pieces that they're not using. And as soon as they need one of my pieces, they get to take it. So anybody recognize what this is? Enterprise. So this was a Enterprise with under 10 pieces. So this was actually built in the new Sawyer library, where they have those little Lego areas down near the printing. So not using any really good pieces. What can you do with minimal sets? So I'm happy to buy a couple of just sets and have us just explore. It's often fun to see what you can do without the pieces you want. I sent you a picture, I think, of a semi-crappy robot I built while my kids were building small little dinky Star Wars Lego sets. And frequently, it's actually better to do something like this. Because if you have the pieces you want, you're not going to come up with new creative solutions, which could be useful for other things. Okay, so just plan for the course. The first week, we're not going to be doing too much in here because I have to go to the joint meetings in Atlanta. So I will be gone sometime this afternoon, American Airlines willing, and then I will be back Saturday, Sunday again, American Airlines willing. And then we'll really kick into high gear the following week. I will give you some stuff to be reading and thinking about. I'll give you some options. For those of you who are going to the elementary school, you'll be running the course in my absence for the first Wednesday, but for the subsequent Wednesdays, I will always be there. So I've talked about using Legos as a springboard. If we are going to be doing the Lego idea, we have some time to just brainstorm first what would we want to build. And then start building it. Same thing for the MLK, if we want to do the bridge again. There's definitely interest on behalf of the committees for us to do something like that. One of the problems is if you buy Lego pieces from the Lego site, it's almost shipped at the speed of molasses. We might be able to get it before the freshmen graduate. It's that bad. Amazon is much faster. So if there are pieces you think you might need, I've got a bunch of general Legos I'll just throw in, but if there are things you want, if there are sets you want, if there are big bags of pieces on Amazon, let me know and I will start ordering them now. Because if we wait, it's going to be hard. I have a lot of Technic pieces which worked very well for the Lego bridge build last year. And I'll bring them all out next week. But again, start thinking about what you might want if you want to do the Lego idea, if you want to do the MLK. In previous years, we've actually done speed builds. So the first slide had a picture of the Superstar Destroyer. 3,152 pieces. The goal was to build it in under 10 minutes. The first year we missed by 20 odd seconds. And the reason was we didn't have enough people in the class. And so we were dynamically moving people from group to group. And the very last thing that had to be connected was built backwards. And so we're under 10 minutes, they go to put the last thing in and it doesn't fit. And fortunately, I don't think the tape hears the student swearing, but he quickly takes it and starts reassembling it and building it the other way, but we end up missing. Fortunately, I had another box, opened it up, and as we were moving people dynamically and they were coming back, they dropped one of the big wings for the Superstar Destroyer. And they had to decide, should we rebuild it from scratch and just completely tear it apart, or should we try to fix it from where it is? They decided to try to fix it from where it is, which is something they hadn't done before, and they were off by one dot, by one row. And so we took over 11 minutes. The following year, we increased the class. We had 60 plus people. We had more elementary school kids, and we were able to do it in under 9 minutes. If you want to do a speed build, let me know, and we can try to find a good set. The Superstar Destroyer is very nice. It can be broken up into lots of individual parts. It is a function of how many people you have, and can you get people working in such a way that they don't get in each other's way, which is highly non-trivial. How do you actually get something like this where you can get down to a really good time so that you now know which way to do things? Do you think you build things the way the instructions are? Do you think that's the best way? Well, I see you shaking your head. So you think the Lego Corporation is not giving us the best instructions to build a Superstar Destroyer? It's going to be the easiest. Or what else? It's not necessarily easiest. It could be, but that's...
Easiest to understand on paper.
So one is easiest to understand on paper, but there's something more than just that. Yes?
Maybe the most time-consuming one, because they don't want kids to get bored, because that's too easy.
So that's an interesting question, is do they actually want to have things take a lot of time? I know somebody who used to work in high tech who was sent to a company to help them install the new system and was surprised because he could install 10 or 15 of them in a half hour, and these people were only able to install 1 or 2. And they said, well, we've been told by our bosses that we can't install them too quickly, because if we do, then the company won't have to hire enough workers. And what happened was, this was making steel for a car plant. And the steel company was right next to the car plant. In the end, it was cheaper for the car company to get the steel from Europe than from the steel plant right next door because it was so inefficient. So sometimes you actually do want to do things inefficiently. If you're being paid by the hour, that's definitely one possibility. I know people who do that. But there's another reason why the Lego instructions may not be good for a speed build. Yeah, they're designed probably for 1 or 2 people, maybe a parent and a kid, or 2 kids, so that the parents have some time to get work done. They're not designed for 60 people working together. And so the question becomes, how would you redesign if your goal now is to minimize time? So there's a lot of interesting things. If you want to do a speed build, there's a lot of things you can learn from doing something like that. Okay, these are just some ads. I'll put all these. When we actually had the Superstar build, this just gives you a sense of the complexity of the task. The first time we did it, we had 1 second in command. The next year, we moved up to 4 people. There were 7 bags, 7 bag captains, 7 assistant bag captains, 7 sorters. Yes, someone's job was to figure out how to sort the pieces. There are certain pieces that are hard to find, but were needed at key moments. Okay, so there's a lot of stuff in something like this. All right, so possible activities. I've talked about the elementary school. When my brother was getting married, a couple of his friends from work chipped in and bought the Millennium Falcon, so the 5,000-piece set. So if people are interested, we started to assemble that last year to do a repair job. If people want to finish it, I am happy to finish it this year. We can do that at some point. If people want to watch some of the Lego movies, that's absolutely fine. Okay. Grading, there should be some grades for this course, right? We should be doing something. So this is a rough idea of ways to do some of the grading, but I am definitely open to other suggestions. All right. So this is a Lego X-Wing. When you see a set like this, what are the first things that come to mind? Yes?
How well does it replicate like the actual?
Yeah, so how well does it actually replicate? There was the life-size X-Wing that they built and had in Times Square. My father-in-law got to see that. Sadly, we do not have the budget for something like that. But we do have a budget for something small like this, and I think it's actually a pretty good job. It does a nice job. They've had several different models of X-Wings over the years that are all roughly the same. Why do they have several different models? Yes? So you'll buy them. How many of you have taken Calc 1? Excellent. What edition book did you use? Or Calc 2 or Calc 3? Were you using the first edition of a calculus book? No. 7th edition, 8th edition, 9th edition? How much of a difference do you think there is between the editions? Yeah. Well, they sometimes change the order of the homework problem so that you can't just assign problem number 15. If you Google integral house, you can see the house that somebody was able to buy with the sales from one of the calculus books. So one of the reasons they do stuff like this is to get people to buy more. Sometimes they actually come up with better ideas and they have better ways to have the wings lock and expand and whatnot. Or now we have new Star Wars movie, we have The Force Awakens, and I think some of the X-Wings were blue, right? So you get to buy whole new sets now with the blue X-Wing. What else do you think of when you see a Lego set like this? Yes?
Can I rebuild it into something else?
Yeah, so one thing hopefully is, can I rebuild it? I sadly think a lot of kids today don't think that anymore, but does it have good pieces that I'll like? What else? Yes?
Is it a collection?
So is it a collection? In what sense?
Like, do I have to buy more pieces to assemble all of Star Wars?
Right, and so if you buy some of these Lego Mindstorms, you actually have to buy separately batteries if you want things to move. So, I just got the Ferris wheel, which we're working on at home. If you buy the batteries, the Ferris wheel can be automated. But I have 2 little kids, so you don't really need the batteries. So one is, what else do I need to truly enjoy it? And again, for the Lego Corporation, the X-Wing is not nearly as much fun as if you also bought the TIE Fighter. And Amazon, in fact, will now recommend when you go and look at people who have bought the X-Wing have also enjoyed buying this. You can buy them together for the same cost as the 2 of them individually. What else should you be thinking of when you see a Lego set? Yes? Thank you. When in doubt, always think about cost. How much is this set? What's a good way to... So one of the big things is finding the right statistic. How many baseball fans do we have here? Okay, what is the worst statistic in baseball? I'm sorry? Wins is pretty bad. Anything else? I'm sorry? Batting average. Oh, batting average is not. I mean, it's not great, but it's not horrible. This is a statistic I truly hate for pitchers. Nope. Strikeouts is actually a pretty good statistic. That's one of the things that the pitcher controls. Can they strike out a batter? Can they walk a batter? Do they give up home runs? Batting average, balls in play, these are more advanced statistics. There's a really bad statistic for relief pitcher. Losses is related to wins. It's not a horrible statistic. But again, with wins and losses, a lot of this, it's bad because it's a function of how well your team does. I will not talk about whether or not Roger Clemens added things naturally or unnaturally to himself in the twilight of his career, but he was pitching for the Houston Astros, and his ERA, earned run average, was extremely low. He was giving up very few runs per game, but was losing a lot because the Astros just weren't scoring runs. And so if you don't have good run support from your team, you could be pitching well and be getting a loss. Conversely, you could be pitching poorly and getting a win if you have a very strong offensive team. So wins and losses is bad. I do think there's a statistic worse than wins and losses for relief pitchers. Which one? Saves. When you hear the word save, even if you haven't had too much experience with baseball, when you hear the word save, you think, oh my God, we were in danger and this person saved the day. You think this is something good. Can anybody give me the definition of a save?
It's if your team is winning by 3 or less runs and you go in and pitch the last inning, then you get a save, or
Doesn't have to be the last inning.
it's last inning or the last 3 innings, and it doesn't matter how many.
Right. It's the last out. Not even the whole inning, the last out. You can come in with a 3-run lead, bases empty, and you're really bad up for the team. You can give up 2 runs and then get the next guy out and get the save. They sometimes talk about vulture saves or vulture wins, where you come in and you create a situation. So ERA, earned run average, is the number of runs you give up per 9 innings. Lower is better. You want to give up fewer runs. The whole point of this is to talk about finding good statistics. The Red Sox had a pitcher a couple of years ago named Rumlinger. And when he entered the game one day, they did not list his earned run average. The reason they didn't list his earned run average is while he had played for the Red Sox and given up runs, he had yet to get an out. So it was division by 0, and the network did not have the symbol for plus infinity. So they had to do 3 dashes. So I think he came in the 9th inning with the Red Sox up 10-3. He very quickly gave up a grand slam home run. He was able to finally get outs. He got 3 outs. The Red Sox won the game. They only brought him in because it was such a big lead. They didn't want to waste a good pitcher. He got a save. The even worse story is the Texas Rangers were playing the Baltimore Orioles in Texas, I believe. After 6 innings, Texas was leading 14-3. So that's an 11-run lead. There's 3 outs an inning. So if there's 3 innings to play, how many outs are left to get for Texas to win the game? 9. They're up by 11. You can alternate home run out, home run out, home run out, and still win the game. Texas brings in a relief pitcher who pitches 3 innings without giving up any runs. Meanwhile, Texas bats twice more and scores 16 additional runs and wins the game 30-3. The pitcher comes in with an 11-run lead, gets an additional 16-run support, and ends up with the save. The save is a bad statistic. How many of you have seen the movie Moneyball or read the book? So it's all about finding the right statistic. And Billy Beane for the Oakland A's knew that certain statistics were not being valued properly in the baseball community. And so what he would do is he would run up some of his plays. Oh, you want my star reliever with all those saves? Oh, it's so painful to think about trading him. But I do need a second baseman. Okay, I'll make the trade. Now, you can only do this so many times before people catch on, but you can do it for a while. So if you can find the right statistic, what statistic do you want to look at to measure the value of a set? Dollars per brick, or cent per brick, pieces per dollar, pieces per cent, something like that. That's not a bad metric. So let's look. So this set, 560 pieces for $120, or 21 cents per piece. So CPP, cents per piece. Seems like a reasonable statistic. Here is a Disney Frozen, 292 pieces for $65 or 22 cents per piece. This was probably the prices last year. I'm sure they've gone up a little bit. But ballpark, these 2 sets cost about the same. Are you surprised? Why would you be surprised? Yes?
Why did Legos get so expensive?
Well, why do you think these sets are a little bit more expensive?
Because they're branded.
They're branded. This is now the Frozen. right? And the other one is the Star Wars. And so as soon as you put that on, you are now paying extra money for that. So Lego does have to increase. So it would be interesting to look at how much does the generic Lego City or the Lego Dinosaur cost, or the Lego Friends line cost per piece. Is there a noticeable difference as a function of whether or not it's some brand? Why else might you be surprised that these are the same, roughly? Yes?
The Frozen set might have more ornamental pieces,
Okay.
and those would cost as the same, those would count as the same piece. For example, like a 2x4 Lego brick.
Ah, so I mean, if you looked at the Superstar Destroyer, that has a lot of very similar pieces, and a lot of them are standard pieces. So one of the big issues, Lego had a period of time when it was becoming very unprofitable, and the company was in dire straits. And part of it was they were giving too much reign to a lot of the designers who would put out these specialty pieces. And they would be very expensive to build and produce. And so you really wanted to rein them in and say, try to use the standard pieces as much as possible. The more special pieces you have, the more expensive the set is going to be to make. So one interesting question might be, are there more specialty pieces in the Frozen that's somehow counting? But why, you've got 292 pieces for $65, 560 pieces for $120, they cost about the same. Why might I say that this set should cost less per piece? Yes?
Because most of the pieces that are being used to just build one object, and you can't really interact with pieces individually, whereas the Frozen one, you have all the interactive stuff that each piece is more useful, I guess, in the...
No. I mean, I'm trying to. Yeah, it has like 2 photon torpedoes that I can launch at the Frozen Castle. We can do strafing runs and bombing attacks, and we have little people we can send out with lightsabers to go against Elsa. If we actually want to do this, I'm sure I can find them from our house. But there's another reason why you might expect the X-Wing to cost less per piece. Volume. Right? If you buy in greater bulks, you often get a better deal. If you go to the supermarket, you can have the small can of peanut butter and the large can of peanut butter. The large can of peanut butter, not surprisingly, costs more. Not always, but usually it costs less per unit because they give you some discount for buying in bulk. So there's actually no discount in these two in buying in bulk, which I actually find interesting. Here is the Superstar Destroyer. 3,152 pieces. When I first taught this class, it was costing about $450. Now it's costing about $1,000. Yeah. I'll just jump ahead. The Millennium Falcon is now selling for $6,000 in an unopened box. My brother is kicking himself that they opened it. And so here, the cost per piece is about 19 to 25 cents. Here, for the Tower Bridge, it's about 5.6 cents. Why do you think the Tower Bridge is so much less? Now, it does have more pieces, so maybe it's the volume discount. It's got about a third more, or the other one has about a quarter less, depending on how you want to do the mathematics. Yes?
Less demand.
So one is less demand. The Tower Bridge, it's a nice set, but it's not as exciting. Why else?
Well, royalties owed to the occupants from London Bridge a long time ago.
Ah! And in fact, where is the London Bridge now? Where? I believe the London Bridge is... Somebody Google the London Bridge. Somebody must have a phone or something.
Well, that's not the London Bridge, that's the Tower.
That's the Tower Bridge. Oh, I'm trying to remember if it's the Tower Bridge or the... Right. That's the Tower Bridge. No, I thought one of the London bridges was actually moved to the United States. It may not be this one, but I think one of the bridges was actually bought and just moved. So one thing is that there's no copyright. So are we really paying this much for Star Wars? Is there really that much of a demand? But look at the sets. The other thing is a lot of these are just really small, 1 by 1 by 3 pieces. And so it's not as exciting of a set. So we need a better way to measure complexity of a set. We need some really good statistics. So cost per piece, it's a simple thing to use. You can start to have more involved metrics. You can also take into account, is this a premium line? Is this coming from some brand that people care about? There's another way to try to measure the complexity of a set. So one thing is we're trying to look at cost per piece size. How else, if I give you a set, what else might you want to look at to try to get a sense of how complex it is? Let's see if this actually shows it. This one does not show it. So what else could you look at when you're trying to decide about the complexity of a set?
You could look at how many of the same type of pieces there are.
Good. How many of the same types of pieces? Or related to that, how many different types of pieces do you get in the set? As the set size increases, what do you think happens? Yes?
Diminishing returns. So maybe small sets will have a lot of different types of pieces, and you'll get more types of pieces the bigger you get, but you'll get fewer.
So probably the bigger the set, the more specialty pieces we get, but the rate of increase is probably slowing down. This is actually related to evolution. You're getting to more and more complex. How many different constituents do you have? And so I'll give you some papers to look at, and there's some beautiful curve fitting about the number of types of different specialty pieces as a function of the size of the set. I do not think the Lego engineers are sitting down and looking at these complexity curves, but a lot of these things just naturally flow in terms of the analysis that you're doing. So we talked about that. I just thought it would be fun to just show a few art pictures. For a while, we actually had a lot of these exhibited at Mass MoCA, but they've replaced it with other works of art. All right, playing card. All right, and so I will turn this off at this point. Okay. Okay. All right, so I want to just talk a little bit about some Lego math, and we'll save more of the math for next week. Okay, and this is a standard 2 by 4 full thickness brick. This is another similar one, but it's thin. Okay, everybody has seen bricks like this before. So even if you can't see me, you can at least visualize them in your mind. One of the more interesting questions that people asked, and then I think this was in one of the original Lego patents, was if I give you a couple of bricks, how many different things can you build? And so the idea is to basically say, this is a great toy. Look at all the different things you can build. Of the things you can build, how many of them are crap? Roughly. Almost 100%, right? Most things are going to just be messes that nobody would want. But if you put the pieces together nicely. So my first question is, how many ways can I combine two 2 by 4 bricks? And then what they used in the Lego patent, I think, was they gave you 6 of them. Now, whenever you do a math problem, before you do a very difficult problem, what should you do? The simplest case. So rather than doing a 2 by 4 brick, what should we do? 1 by 1. All right. How many ways can I combine them? 2. Okay, why 2? Yes?
Well, are we treating them as different or the same?
So am I doing 2 greens, or am I doing a green and a yellow? So you have to be very careful as to which problem are you doing. Or just a yellow. Right. So let's say we're doing 2 greens. We have some nice combinatorics of permutations if we allow different colors. How many ways can I combine 2 greens? Does everybody get 1? Does anybody get anything other than 1? Yes?
If you count unattached, then you have 2.
Oh, I have 2 if they're unattached, right? Well, actually, I could put them diagonally, right? So one of the rules of the game, and you have to put in rules, is to say, I've got to be able to, pick them up, and it will all stay together and connected. If you want, you can imagine you're doing this in a vacuum of space. So if they're just touching like this and they're not connected, that won't count. How many ways are there now? How many ways now? All right, do we all agree that it's now just one way? Does anybody get anything other than 1? So I'm the only one who sees another way of doing it? Yes?
Could you do it from, can you flip it? So
Ah!
well, the pieces, so like, because it's,
Yes. So I could have the point going down rather than the point going up. Or the point going sideways. So, yes.
you can also rotate them relative to each
Right.
other.
Right, so good. So one thing is, if I go like this, do I really consider these fundamentally different? If I had my 7-year-old daughter here, my son's getting a little bit heavy, I would be picking up my daughter and spinning her like this. It doesn't really matter. So we will count this and this the same. Anything that we can move just by rotation or in translation, we're going to consider equivalent. And the next remark was that, well, what if we just spin the top? Those are now distinct. How many different solutions do we have now? How many? Infinitely many. Well, the problem doesn't become that interesting now, because if I have 2 pieces, I can connect them on a corner, and I just have infinitely many angles. So what can we do to try to make the problem more reasonable?
Only do right angle.
Only right angle connections. So if I do 2 1-by-1 pieces, how many ways are there? So I'm counting rotations and translations as equivalent. How many ways? Do we all agree now that there's just 1? And then we'll assume color doesn't matter. If I add a 3rd piece, how many ways? If I add a 4th piece. So it's really not that difficult to count how many ways there are to connect n 1-by-1 Lego pieces. So we could say f1 of n is equal to the number of ways to connect n 1-by-1 Lego bricks. You're not supposed to say Legos. And so our first theorem of the class, f1 of n equals, which is, I heard n and I heard 1. 1. So with our definition of connect, there's only one way to do it. Okay. What should we look at next?
Well, 2-by-1.
So one is to do the 2-by-1. Does it matter if it's a thin or a thick? No, it doesn't matter. And again, we're not going to allow something like this. When you're actually building, it's nice to be able to do that. We're not going to allow something like that. They've got to be right angles. This is fine. This is not fine. Okay? So as a nice exercise, what would f2 of n be? Is there a nice formula for that? How quickly does it grow? When you have 6 bricks, how quickly does it grow? And then there was some dispute as to how this should be counted initially. When you have 6 bricks, does it have to be a tower of height 6? I could have, 2 things like this. I could connect them like this, and I could just keep going around and keep it to just be a height 2. And so, depending on how you want to count things, it can be a lot easier or harder. How many of you have ever played Tic Tac Toe? I believe I currently am the undisputed champion at the elementary school playground, although I haven't really played the kids for a while. I have tied one game, and I think I've beaten everybody else. All right, everybody has played Tic Tac Toe? How many opening moves are there in Tic Tac Toe? 9. Up to symmetry, how many opening moves are there? 3. Center, corner, and middle. So there's really only 3 openings. Okay? If you looked at it as there are 9 possible openings, how many possible responses are there? 8. So there would be 72 possible configurations after the first 2 moves. But a lot of them collapsed to being equivalent, and there were really only 12 distinct things to look at. This is how you can analyze tic-tac-toe very easily. Does anybody still enjoy playing tic-tac-toe? Good. Why not? Sorry. Why not? It's boring, right? Does anybody know how to make tic-tac-toe fun?
It's equivalent to another game about adding numbers. That's kind of interesting.
Okay, yes, you can do it that way, and I've actually seen that at the Museum of Science. There's at least 3 or 4 different ways to make tic-tac-toe interesting. If you are a math or stats major at Williams College, we require you to give a 20 to 40 minute colloquium to graduate. Anybody here planning on being a professional mime? If so, speak up. Oh no, that would be inappropriate. If so, raise your hand. You need to be able to present information. You need to be able to talk. How do you present technical information? So I had a colloquium student this year who actually gave a talk on one of the interesting ways to play tic-tac-toe. What you do is each person starts off with a certain amount of money, probably pretend money. And you have secret bids. And whoever bids the most gets the move. And there are 2 ways to play. One way is the money that's from the successful bidder goes to the bank and is out of play. The other way is it goes to the person who lost the bid. And there are things you can do if it's a tie. You can have a special coin in terms of who gets to choose. I actually like having a tie mean you have to bid again. So the game is completely symmetric. And so now you have to decide how much do you want to bid. So for instance, let's say we each start off with $1,000. How much is that first move worth it to you? Is there anybody here who really, really, really wants to go first against me? Okay. How much will you bid?
$500. $800. $1,000.
We'll do $800. So you bid $800. I'll bid $200. So you get the first move. Where would you like to go? Corner. Interesting. Really? Okay. So now, how much money do you have? You have $200. And again, I asked you to overbid, and I appreciate you overbidding. I now have $1,800. Now, I've lost the first move. What's my objective now?
Just need to bet more than him 3 times in a row.
3 times no. I want to control the next 3 moves. How much should I bet on the next move? 201. Let's just do $200 just for simplicity. All right. So we don't have to deal with subtraction this early in the morning. Okay? You can do it. It's not going to make a huge difference. So I'll bet $200. You bet $199. I get the next move. So I would go to $1,600, and you would have $400. I'll go here. Now what do I do? $400. Technically, I'd be betting $401, but we don't care. So I would go down to $1,200. You would go up to $800. I'll go here. And you can see the extra $2 or $3 is not going to make a difference. Now how much do I bet? 800. It doesn't really matter. It's pretend money. It doesn't matter who has the money at the end of the game. I can outbid. And so there is a completely deterministic strategy as to what you should do in a game like this. But it's not a strategy most people know, and it's not as intuitive. So something like this will make the game of tic-tac-toe fun again. Okay? So you really want to figure out how to analyze things. And so you want to figure out how to count things. So when we're trying to do bricks, how many ways can I combine two 2x4 bricks and have them connected right angles? You want to go through in such a way that you do not forget about cases. So without loss of generality, what can we assume about the orientation of the first piece? Stationary. Might as well have it oriented north-south. I am from Boston. I hate New York City. But there is one thing I have to admit, at least a subset of New York City does better than most of Boston. Yes, the grid in Manhattan. You know, if you've driven in Boston, where you have Comm Ave and Beacon Hill crossing and interchanging as to which one is above the other. You know, if you have grown up in the area, you can figure out how to get around. But otherwise, Boston is a nightmare. New York City, the grid is very nice. We might as well assume our first piece is oriented north-south. For the second piece, how many cases do we have? Yes, 2. North-south, east-west. If we do north-south, we have 1. We can go down 2, right? 3, 4, 5, 6, 7. And then the question is this different than this? Yes or no? So I'll show it on some of the smaller bricks. So in one, it's attached in the upper right, and the other, it's attached in the bottom left. I mean, in the bottom right. Are they different? Depends on your definition. Can I rotate them to be the same? Mirror image, though, are they the same? So in mirror image, they would be the same. So do we consider mirror images equivalent or not equivalent? I mean, we could have, I mean, there's a glass window behind you. We've got people observing you. Sorry. If you see a mirror image, is it different, yes or no? This would be a wonderful opportunity to have a biology or chemistry major here. Mirror images of some compounds can kill you, while the other one could actually save your life. And so for certain things, it actually matters. And the word is chirality. And so depending on whether or not you want to consider something like that different or not, you will change. If you are trying to write a computer program, and for those of you who, how many of you have never programmed? This is a great opportunity to do a bunch of for loops and to do some basic programming. I'm happy to talk to people and give you some lessons in how to program. How would you try to count all the different possible configurations? How would you write a good way to methodically go through all the possibilities? If I don't have to worry about which ones are similar, it's much easier to count. And so for a lot of problems, it's actually easier not to build in symmetries, because it takes more time to code them than to solve them. I'll give you a nice math challenge. Take the digits 1 through 9, and anybody who was not here today will have to actually come up with a solution. So one of the advantages of actually traveling here. And you can, so you take the digits 1 through 9, and you form 3 fractions. A over 10b plus c plus d over 10e plus f plus g over 10i plus j. If you put in the numbers 1 through 9 correctly for a through j, it will sum to 1. So I first heard this problem years ago when I was at a math institute. And I was there surrounded by some of the top number theorists in the world. What do you think they started to do? I'm sorry? They were proving it. They would try to prove things about where certain digits must be located. And they would have all these partial lemmas to restrict your search space. I'm a good number theorist. I'm not top in the world. I often say things that people top in the world want to hear. What do you think I did? What do you think I did? I'm sorry? Close to guess and check. I'm sorry?
You'd take one of those.
Nope. Coded it. How many ways are there to place the 9 numbers? 9 times 8 times 7. 9 factorial is not that large. And in fact, you can switch things a little bit in that it doesn't really matter the order in which I write the fractions. But 9 factorial is such a small number for the computers to just quickly check. It took less time to write a dinky program to just go through all the cases than it took to actually think about results. The reason is we only have to run the program once. So because I only have to run the program once, it's not worth writing a good program to do this. It would take me more time to write a good program than I would save in a reduced runtime. And so you really want to be thinking about how you're going to be using something. And depending on what you want to do, there's a lot of great computational savings you can do. So when we're trying to calculate how many different ways, and there's been some good math papers written about trying to count the number of ways to combine Legos under these right-angle rules where it must be a connected structure. It's very hard when you allow rotations and translations and whatnot to be considered the same. If it's not the same, then it's much, much easier. But a lot of the structures are the same. If I go like this, that's also the same as this. And as you start having more and more levels, it can become harder and harder and harder. At least we have the dots on it, so that this is different than putting it over like that. Okay. Trying to think what else to do today. So we've talked about chirality, we've talked about mirror images, programming. We've talked about finding the right quantity. And so, I'll send you an article to read about the complexity of Legos. I'll just end with one last thing, and then we'll talk about the different groups. How many of you have not done a Sudoku? All right, everyone here has done a Sudoku. All right, what size Sudokus do you guys normally do?
9 by 9.
Oh, just 9 by 9. Okay, 9 by 9. Okay. So what's the goal in a 9 by 9 Sudoku? Okay, so in each row, in each column, and then we'll also have these blocks. And we need all the numbers 1 through 9 in each of them. How do you tell if you have 1 through 9 in a column? Yes? I'm sorry?
If you don't repeat any numbers.
So you would have to, so you would be checking and seeing, is every number distinct from every other? So would you go through and say, I'll take my first number and see is it distinct from the 8 that follow it. Then I'll take the second number and see if it's distinct from the 7 that follow it. And then the third number and see if it's distinct from the 6 that follow it. That's one way to check. Any other ways you could check? Count how? Okay, so go through the whole list. Do I have a 1? And as soon as I have a 1, terminate. Do I have a 2? Terminate. And if you want, you could even remove the 1 from the list once you found it, so that it would be a little bit faster. This is a lot of checks. Worst case, the number of checks is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, which is the same as 45. So you'd have 45 checks. I can do it in 1 check. Yes?
Well, you know that the sum of the first 9 numbers is 45, so you can sum the row. If it's not 45, then you must have something wrong.
Ah, but what if I have 1, 2, 8, 9? That works, or 2, 2, 8, 8. So they have the same sum, yes. But you're very close, yes.
Multiply together prime numbers.
So one possibility is to have my numbers be primes. 2, 3, 5, 7. I'm a number theorist, I love primes, yes.
Could you assign like 1, 2 as like 1, 10,
Yep.
100, 1000?
This is the easier way. So have your numbers in your Sudoku be 1, 10, 100, 1,000, 10,000. And now, if you add them up, if you have 1 of each, what's your sum? 1, 1, 1, 1, 1, 1, 1, 1, 1. And that's the only way you can get 1, 1, 1, 1, 1, 1, 1, 1, 1, is to have one of each. So now it's just one check. Does it really matter if you use 1 through 9 or 1, 10, 100, 1,000? Maybe if you're on the airplane and you're trying to write on the little magazine, it might be a little bit hard to be writing the 100,000. And I don't even want to think about the million and higher. But if you're writing it on a computer program, there's really no difference in terms of how you use it. But by taking the right perspective, you can make your computation significantly easier. You can cut down on the number of things to check. You can decrease the runtime. So again, part of the purpose of a winter study is for you to explore things you may not have seen before. You can use the Legos as a springboard. All right, so I think this is enough content right now. So what I'll do is just have you guys split up a little bit. And if you want to work on multiple things, that's great. I want to see who's interested in going to the elementary school, especially since that's happening tomorrow. Who's interested in doing a Lego challenge? Who is interested in working on the MLK? And then if there's anything else that I'm missing, yell it out right now. Okay.